Hey there guys, Mr. Wilhelm here, back again. Today we're going to talk about graphing. If you have not already done so, please make sure that you have your notes out in front of you, your introduction to graphing notes. If you don't have a copy of the notes, you can get those from my class website on the class notes page, simply titled Introduction to Graphing Notes. So make sure you have those notes out in front of you right now so you can fill out those notes as we go along. So today we're going to talk about graphs. First off, why do we use graphs? Well, graphs simply provide us with pictures, quick snapshots of information. It's a quick, fast, and easy way to interpret data. Right here I have a graph of birthdays of students by various months, and I can look at this, not even have to worry about really analyzing the numbers, and I can see quickly that in May, we have the most students in May have birthdays. Okay? In November, there are no birthdays. Second most birthdays a month would be December. So it's a quick way of seeing information, a very easy way to analyze data. There are three major types of graphs. Okay? We have bar graphs, pie graphs, also known as circle graphs, and line graphs. Okay? All of these are going to display different types of information. For example, a bar graph is best used for comparing data quickly and easily. If I'm comparing numbers or comparing one thing to another, I would use a bar graph. Pie graphs are usually used when we're looking at percentages or parts of a whole. Okay? And then line graphs are usually used when we're looking at changes over time. How something's going to increase or decrease over a specific time period, whether that's seconds, minutes, hours, days, months, years, or whatever that may be. These are the three major types. There are other types of graphs out there, obviously, but these are the graphs that we will usually use in science. So here is a sample. Here is a data table providing us with information. So let's see if we can analyze this and figure out what type of graph that we would use. We have basically various foods and rabbits' diets up here. Lists a series of foods: Skippy's Rabbit Chow, homemade rabbit food, Happy Rabbit, Joe's Special Food for Rabbits, and Premium Rabbit Nutrition Diet. And we can see that we have percentages of foods, of rabbits that prefer these foods. Okay, 32% of our rabbits prefer Skippy's Rabbit Chow, while 44% of our rabbits prefer Joe's Special Food for Rabbits. And we only got 1% of our rabbits, okay, that prefer Premium Rabbit Nutrition Diet. Okay? So here I'm looking at percentages. I'm looking at various parts of a whole. If I would go through and add all these numbers up, all those numbers are going to be added up, they're going to equal 100. Okay? So in this particular situation, I would use a pie graph, okay, also known as a circle graph. But I would use a pie graph right here in order to display this information, because there are percentages involved and we're looking at parts of a whole. Here's another data table displaying some information. Let's going to analyze this particular data table and figure out what type of graph we would use to display this data. Here I have science grades over a course of several months, September through April. I can see that science grades started off nice and high, 98% for this particular student or class in September. Goes down slightly in October, goes down a little bit more in December, and a little bit more in January, but then we get a boost in, December, and then we get a boost in January and on up. Okay? So here we're looking at a change, how the grade is fluctuating up and down. We're not only looking at a change, but we're looking at a change over a specific time period. So anytime we're looking at a change over time, we would use a line graph to display that information. Let's go ahead and look at another example. Here I've got another example of a data table, and let's analyze this and figure out what type of graph we would use to display this information. You have pH of solutions. pH is simply determining if something is acidic or basic. In chemistry class, we've got various test tubes, and then we have various pH values for each one of those test tubes. We can see that roughly test tube 2 and test tube 4 here, and almost 5 are about neutral, where the others are slightly acidic. So here I've got various test tubes and various pH values. I'm comparing, there's the key word, comparing one test tube to the other. Okay. Therefore, since I'm comparing data, I'm comparing information, comparing values, I would use a bar graph in that particular situation. Okay, so you guys are going to be required to not only read graphs, but to construct graphs. Okay, so here are some components of a good graph. Okay, graphs require the correct ingredients or components to make them readable and understandable. If you don't have the right components in your graph, others are not going to be able to understand the information that you're providing in your graph. Okay? In a graph, we have a x and y axis. Okay? The x-axis is the axis on bottom. This is the horizontal axis. Okay? The y-axis, that is the one that goes up. That is the vertical axis. Okay? So we will always refer to either the y or x-axis in a graph when we're putting in data and scales and so forth. Okay? Now, what goes on the x and y axis? Well, we've been working in class and identifying independent and dependent variables. So we would, whenever we're doing an experiment, once we have the independent and dependent variables identified, it gets really, really easy to figure out where they go. And we have a little memory tool to help us remember the x and y axis and which particular piece of information goes on each. Okay? The dependent variable, also known as the responding variable, okay? This is placed on the the y-axis. We have dependent variable, also known as responding variable, goes on the y. That simply spells the word dry, D-R-Y, dry. Okay? So that's we would put the dependent variable, responding variable on the y-axis. Okay? Then we have the manipulated variable, okay, also known as the independent variable, and we're going to place that variable on the x-axis. That gives us mix, okay, manipulated or independent variable on the x-axis. So it's a real easy memory tool, dry mix. Dry mix. If you can remember dry mix, you can easily remember where the independent and dependent variables go on your graph. More components of a good graph. We always want to choose a scale for each one of the axes on our graph. Okay, we want to evenly space out our scale, and we also want to label and use the appropriate units. Here's a particular example. We're talking about particular profits over a course of time. We're going to use a line graph. Again, we're looking at a change over a course of time, so it's a line graph. Over here we have the profit in dollars, $20,000, $60,000, $100,000, evenly spaced. And we've got October, November, and December evenly spaced as being our time period. This would be considered our scale. Okay, the numbers that we're using to represent the values on this axis. And here is our other scale. Okay, the time periods that we're representing here on this particular axis. So we have the scale, which are this part and this part, and then we also have our labels to that scale. Okay. Right here, profits in dollars, months. If we simply put 1,000, 100K, 60K, and 20K without any type of label, we wouldn't. The person trying to read the graph, they wouldn't understand what that's all about. Okay, they would have no clue. Are they talking about, we're talking about money? Or are we talking about time? Are we talking about rocks? What are we talking about? So we have to provide a label. Okay, whenever we put that on our graph. A couple more components of a good graph. Okay? Legends. You guys have learned about legends before. Legends identify which each one of these particular lines are associated with. Obviously the green is talking about profits that occur in Texas, whereas blue is in California, and then the red is in Nevada. Okay? So we have these colors, and they coordinate to those lines, and they explain basically what those lines are showing us. Almost done with this. Components of a good graph. We always want to include a title. Titles are very, very, very important. Okay? Titles in a graph are going to show exactly what the graph is about. So when the person looking at this graph, as soon as they open up to the graph, they can see instantly, okay, this graph is telling me what this particular piece of information is trying to illustrate or display. Okay? Title tells the reader what he or she is studying, and a good title should also explain the relationship between the variables. Okay? Again, down here we have our x-axis. This is our mix. This is our manipulated variable or independent variable. Over here we have our y-axis. This is the dry, okay, the dependent or dependent or responding variable. All right, almost done here. Pie graphs are shaped like a circle. Each of the slices will show us the particular percentage that is represented. Okay? The independent variable is whatever the slice of the pie represents. The dependent variable is the size of the slice. Okay? So if it is a large slice of the pie graph, okay, that's going to represent a large percentage. If it's a small slice of the pie graph, that's going to be a small percentage. Okay? And the dependent variable is actually that percentage, that particular part of the percentage of the pie graph. All right. That wraps up talking about graphs. Hope you guys enjoyed your notes and be ready to go and practicing how to make graphs and construct graphs and read graphs when you guys come back next time.